Okay, so extending on our lesson on area of basic shapes, we're going to look at area of regular polygons. Remember, regular polygons are those figures where everything is the same. So if I had a pentagon, then all the sides would be the same, all the angles would be the same, and that goes for any figure whatsoever. If you've got all same sides, all same angles, then that would be regular. So let's talk about how we're going to start with these. Well, first of all, you're going to look at your central angle. So the central angle formula is you take 360 because it is 360 degrees all the way around, and then you're going to divide by the number of sides. So n is for the number of sides. So make yourself a note. N equals number of sides. All right, so now if I'm going to do this, then that means you're going to take this formula, so 360 divided by the number of sides, which is 6, equals 60. So therefore your central angle is 60 degrees. This is going to be very useful. Okay, if we did this one, so this would be 360 degrees all the way around divided by the number of sides. That would be 120 degrees. That's why this angle is 120. This one's 120, and that one's 120. Here we have 4 sides, so we'd have 360 degrees divided by 4 sides, which gives us 90. So that means this is 90, this is 90, this is 90, and that is 90, which we knew because the diagonals of a square are perpendicular. All right, so here's something new, a regular polygon parts. Okay, so we've got 2 parts that are, you know what a radius is. The new word we're going to talk about is called the apothem. I like saying apothem. I think that it's funny. So first of all, let's start with the radius. Okay, the radius starts at the center and it goes to a corner. And if you'll notice, it goes to a corner because the corner is actually touching that circle that goes around the outside. So therefore, the radius is still the radius of a circle. It's just now the radius of your polygon also. Basically, it's part of your diagonal. And then the next thing that you're going to have is called the apothem. Again, you go back to the center and you drop a line straight down and you stop at the polygon. Do not go all to the circle because then you have another radius. I don't want another radius. I want the apothem this time. So this is your apothem, and it is abbreviated with a lowercase a. Okay, so now if you'll notice, you had a hexagon here. You drew a line straight down, and it has to be perpendicular to the base. So now you've got this little right triangle. So you're going to be doing a lot with these. And that's why I pushed the special right triangle rules, because you really have to know them. All right. So let's find the apothem if the side is 6. So if the side of this hexagon is 6, they're all 6. Now here's a trick on hexagons only, is if you know the side, you also know the radius. The radius and the side are always the same in hexagons, so you may want to make yourself a note of that. So in hexagons only, the radius is equal to a side. So make yourself a note. So this is always true, but it's hexagons only. All right, so now they're wanting me to find the apothem. Remember, the apothem is this piece here that goes straight down. So I need to find the apothem. So I'm going to have to do a little bit of math. Well, what I've went ahead and done is I redrew this right triangle that I have here, where this is my apothem, this is my radius. This piece right here is the same as this piece right here, which is half of the side. Well, if the whole side is 6, then the apothem splits it, so this makes this 3. So now I have a right triangle and I know this side. Well, guess what? You also know this angle right here. So if this whole angle is 120 degrees, then half of it is going to be 60, which means this angle up here is 30. So I have a 30, 60, 90. So now we need to think about those rules. Well, across from the 30, we label as x. The hypotenuse is 2x, and this is your weird side, x squared or 3. Well, if x is 3, then 2x would be 6. So my radius would be 6. And the apothem, well, if the x is 3, then this side would be 3 square root of 3. So therefore, your apothem is 3 square root of 3. So you just had to use your 30, 60, 90 rules. Okay, let's do it again. This time they're telling me that to find the apothem when the radius is 8. So if my radius is 8, well, according to my rule, this side is 8. So if the whole side is 8, remember the apothem cuts it in half, so this is 4. So I'm going to go over here. This is 8. This is 4. This is 90. This angle here is 30, and this angle here is 60, because remember, the whole thing is 120, and the radius just so happens to cut it in half. So that's 30, 60. Well, if I label my sides, the short side is x, the hypotenuse is 2x, the weird side is x squared root of 3. Well, if x is 4, then 2x is 8, then this side must be 4 square root of 3. So find the apothem. Well, the apothem is this piece here, which is here. So the apothem is 4 square root of 3. Easy, easy. All right. In a square. Okay, we have lots of formulas we can use for squares. So just remember, in a square, when you cut this in half, remember it was 90. So when I cut it in half, now this is 45. Your apothem is 90 degrees to here. So it says, in a square, given that your apothem is 4. Well, if this side is 4, and this is 45, and this is 45, then guess what? Remember, this is also 4, because it's a 45, 45, 90. So in a 45, 45, 90, if you recall, let's go here. This is x, and this is x square root of 2. Oops, that's a 2. So if my x is 4, then this side is going to be 4 square root of 2. So therefore my radius is 4 square root of 2. And then we have an equilateral triangle. So in an equilateral triangle, your apothem is still 90 degrees to the side. It still cuts the side in half. So let's find the perimeter. Well, if my apothem is the square root of 3, which means that's a 1 in front, so that would be 1 square root of 3. Well, what I'm going to do is I'm going to draw an equilateral I'm going to draw a right triangle over here, which would be this one that I'm looking at. So I'm just going to look at that right triangle there. I know that this is 1 square root of 3. This is 90. If this whole angle is 60, then when I split it, this becomes 30. So I'm going to make this 30. Now this angle up here is 60. So I have another 30, 60, 90 that I'm going to have to contend with. Well, in the rules, across from your 30 is x, your hypotenuse is 2x, and now your weird side is x squared root of 3. It's just the opposite of a hexagon. So here, if x is the square root of 3, so if x is the square root of 3, then this side is going to be 2 times the square root of 3, so this would be 2 square root of 3. So my radius would be 2 square root of 3. The apothem is square root of 3. This side here, well, if x is the square root of 3, that means the square root of 3 times the square root of 3. The square root of 3 times the square root of 3 is just 3. So that means this side is 3, because this is 2 square root of 3. Well, isn't this piece here also 3? So then the whole side would be 6. Well, that means the perimeter would be 3 sides at 6 each. So it would be 18. So my perimeter would be 18. So that's how you go about finding missing pieces. Now we're going to take these and we're going to plug them in and start using this new formula. This is called the area of a regular polygon. You need the apothem, which is that perpendicular part, and you need the perimeter. It looks like this, 1/2 AP, which is how it looks on your formula chart. I always write it like this. I just put PA over 2. Perimeter times apothem, take half. Same thing, divide by 2, take half. This is how I always write it. It means the same thing, so make sure you understand that they are interchangeable. All right, so here we go. I've got a square. They're telling me that the radius is 5 square root of 2. So in a square, I know that these are going to be 45, 45, 90s here. So if in a 45, 45, 90, if this is x square root of 2, the square roots of 2 match up, so that means that my x's, which are these two sides here, have to be 5 each, because the x matches up with 5. So that means my apothem is 5, because that would be this piece here. The perimeter, well, this is 5 also, and that makes the whole side 10. Therefore, my perimeter is 4 sides at 10 each, because it's regular, so they're all the same. So that makes the perimeter 40. So that makes this 40. Now, if I use my new formula, then I'm going to go, well, the area is perimeter times apothem over 2. Perimeter is 40 times the apothem, 5 divided by 2. So 40 times 5 is 200. 200 divided by 2 is, area is 100. Oh, that's an ugly 100. So 100, and this would be units squared, whatever the units may be. The cool thing about a square is we actually have several formulas that we can use because you also have your side squared. So you could have used that one once you knew this. That would have been 10 squared, which would have been 100. And that would have been okay to do too. So depending on what information is given, you actually can use any of the formulas. Okay, so let's try it again. Now this time they're telling me that the apothem is the square root of 3. So that means this is the square root of 3. Well, this and this are always the same when it's a square. So this is the square root of 3. Well, if you'll remember your labels, this is x, this is x, this is x square root of 2. Well, if my x is the square root of 3, so x is the square root of 3 times the square root of 2, then 2 times 3 is 6. So that makes the radius the square root of 6. So I'm going to go over here and I'm going to put, well, that makes the radius the square root of 6. So if this side's the square root of 3, remember the apothem splits it in half. So that's also the square root of 3. So that means the whole side, well, the square root of 3 plus the square root of 3 would just be 2 square root of 3. Well, the perimeter would be 4 sides at 2 square root of 3 each. So 2 times 4 is 8 square root of 3. So now I'm going to go over here and I'm going to put that the perimeter is 8 square root of 3. Well, if I use my newfound formula, that would be perimeter times apothem over 2, where the perimeter is 8 square root of 3 times the apothem, which they gave me to be the square root of 3, divided by 2. So this is 8. Well, what is the square root of 3 times the square root of 3? Well, if you'll remember, it's just 3 divided by 2. 8 times 3 is 24. 24 divided by 2 is 12. So your area is 12. And they didn't give us units, but I know it's going to be units squared. Okay, number 10. We have an equilateral triangle. Well, I told y'all a formula about equilateral triangles that you can use if you know the side. And in this case, I know the side. The side's 8. So obviously I would use that formula where it's side squared, square root of 3 over 4. So that would be 8 squared, square root of 3 over 4. So that would be 64 square root of 3 over 4. And then 64 divided by 4 is 16, so it would be 16 square root of 3. So this is what our answer is going to be here. But we're going to use the new formula so we can practice. So I know that the apothem splits this side in half, so this becomes 4, this becomes 4. This is 90, this was 60, so now this is 30, and this is 60. So now I've got to figure out, well, what is the apothem? Because I need to know that. The perimeter, well, the perimeter is 3 sides at 8 each. So 3 times 4 is 24. So I know my perimeter is 24. So I do need the apothem to use this formula here. Because remember, we're going to check it up against what we found here. So we know this is going to be our answer. So what I'm going to do is I remember that my labels are across from the 30 is x, the hypotenuse is 2x. This side is x square root of 3. Okay, well, if I've got x square root of 3 equals 4, then that means I have to divide by the square root of 3. So if I divide by the square root of 3, remember we have to rationalize the denominator. So x becomes 4 square root of 3 over 3. So there's my apothem. So the apothem is 4 square root of 3 over 3. So that makes this side 8 square root of 3 over 3. So now the area. So now let's use our new formula. Perimeter, 24, times apothem, 4 square root of 3 over 3. And then I have to divide all of that by 2, which is really messy. So let's look at it. So what's 24 times 4? So 24 times 4. So this is 96 square root of 3 over 3 divided by 2. Well, what's 96 divided by 3? Well, it's 32. So now I've got 32 square root of 3 over 2. Because I really haven't done anything with the 2. I just keep playing with the numerator. Now I can do 32 divided by 2, which 32 divided by 2 is, 16 square root of 3. So here's your final answer, which we knew that because we used the easier formula first so we could check against it. So 6 square root of 3 units squared. So sometimes you will have multiple formulas that are okay to use. Just make sure you know how to find what's necessary. And here we go. The last one is another hexagon. I really like hexagons because there's lots of things you already know. For example, the apothem here is 5 square root of 3. So I've redrawn this pink triangle over here. So what I'm going to do is take that triangle and I'm going to go, okay, here's the apothem, which is your 5 square root of 3. And then here's your radius, okay, which would be this piece here. So I know this piece is 5 square root of 3. And remember, the whole angle is 120. So that makes this angle 60, which makes this angle 30. Just keep splitting it in half, basically. So if this is your x, your hypotenuse is your 2x, and your weird side, your x square root of 3. So my apothem is 5 square root of 3. Well, then I just double that to get my radius. So this would be 10 square root of 3. So my radius is 10 square root of 3. And then the perimeter, well, first of all, I need to find this side, which is half, where I can double it. So remember, though, that the radius is always equal to a side. So if this is 10 square root of 3, then that makes your side 10 square root of 3. So if your side is 10 square root of 3, then the perimeter is going to be 6 sides at 10 square root of 3 each. So that means that the whole thing is 60 square root of 3. Well, I have a perimeter and an apothem, so now I can use my formula. So the area is 60 square root of 3 times 5 square root of 3 divided by 2. Well, 60 times 5 is 300. 300 divided by 2 is 150. So that would be 150 times the square root of 3 times the square root of 3 is 3. So 150 times 3 would be 450. So your area is 450. And that is it. So y'all have a great day. See you later.